For centuries, mankind has gazed at the night sky, filled with questions about the mysteries of the universe. In the 20th century, scientists proposed a theory now known as the Big Bang theory. This theory aimed to explain crucial questions about the origin, development, and expansion of the universe. However, despite its widespread acceptance, it struggled to address some key issues. In recent years, new research has added even more complexity to this cosmic puzzle. In 2023, NASA's James Webb Space Telescope made a groundbreaking discovery, a celestial object that appeared to be older than the universe itself. This revelation has left scientists baffled, prompting them to question how a star could exist for a longer period than the universe. Could this discovery challenge our current understanding of the cosmos? Might it even require the conception of a new model to make sense of such an enigma? These are some of the many questions we aim to explore in this video. If you're interested in staying informed about news from the universe and beyond, subscribe to our channel, like this video, and turn on the notification bell. About 200 light-years away, near the constellation Libra, lies an ancient star known as HD 0283. What makes this star particularly intriguing is its surprisingly high velocity, 44,283 kilometers per hour, offering valuable clues about its dramatic past. Approximately a billion years ago, during the formation of our Milky Way, it merged with a dwarf galaxy, which was likely the original home of HD 0283. However, the most fascinating aspect of this star, nicknamed Methuselah after the biblical figure reputed to have lived 969 years, is not its speed but its age. Initial estimates placed the star's age at an astonishing 16 billion years, but more recent measurements revised that figure to 14.46 billion years, with a margin of error of 800 million years. This presents a significant conundrum as it conflicts with the estimated age of the universe, which, based on cosmic microwave background observations, is around 13.8 billion years. The paradox of how a star can be older than the universe itself raises questions about the reliability of our dating methods and whether our current understanding of the universe's age is accurate. Determining the age of celestial objects is an incredibly complex task. Stars like our Sun can maintain a relatively stable temperature and size for billions of years, making their ages difficult to estimate. Astronomers rely on subtle changes in brightness and color over time, comparing those measurements to mathematical models that predict stellar evolution. One crucial indicator of a star's age is its rotation rate. Much like a wheel slows over time due to friction, so do stars. By comparing the rotation rates of stars of various ages, scientists have developed mathematical relationships to estimate their ages using a method called gyrochronology. Methuselah is undeniably ancient. In fact, it is the oldest star in the universe for which we can reasonably estimate an age. Rather than simply accepting that it could be over a billion years older than the universe, perhaps we need to reevaluate our assumptions. Could it be that the universe is older than scientists have previously believed? It is difficult to fully grasp the immensity of 13.8 billion years. If we were to represent the universe's history as a cosmic calendar, with the Big Bang marking the most dazzling New Year's fireworks, Earth would only appear near the end of the year, and all of recorded human history would occupy just the final 10 seconds of December 31st. Scientists calculate the universe's age by observing light from stars formed hundreds of millions of years after the Big Bang. As the universe expands, it causes a redshift in the light of distant objects. By analyzing both this redshift and the distance of observable galaxies, researchers have estimated the universe to be about 13.8 billion years old. However, new findings from researchers at the University of Ottawa suggest the universe may be much older. Around 26.7 billion years, University of Ottawa physicist Professor Rajendra Gupta has proposed a theory that combines Swiss astronomer Fritz Zwicky's 1929 tired light theory with newer concepts. This theory posits that protons lose energy during their journey across vast cosmic distances and time. Although this contradicts conventional interpretations of redshift, Gupta suggests that redshift could be a hybrid phenomenon, partially due to expansion and partially due to energy loss over time. This reinterpretation could significantly extend our estimate of the universe's age and offer explanations for both long-standing cosmological questions and recent observations made by NASA. The James Webb Space Telescope has played a key role in supporting this revised estimate of 26.7 billion years. Gupta's model also incorporates the evolutionary interactions constant, a concept originally proposed by theoretical physicist Paul Dirac, which implies that fundamental interactions may have changed over time. It's important to recognize that our estimates of the universe's age have been revised before. For example, in the 1920s, Edwin Hubble estimated the universe to be only 2 billion years old. Over time, that estimate has increased significantly as our understanding has improved. Gupta's new model marks another important milestone in refining our cosmic timeline. Whether we view human history as 10 seconds or even just 5 seconds, in the grand timescale of the cosmos, one thing is certain: the universe is unimaginably old and filled with wonders that continue to reshape our understanding. In addition to these cosmic revelations, there are fascinating new observations within our own galaxy. Recent measurements suggest that stars in the outer regions of the Milky Way are moving significantly slower than expected when compared to stars in similar positions in other galaxies. This puzzling behavior raises two possible explanations. One is that our galaxy may contain an unusually low amount of dark matter, the mysterious, invisible substance that is thought to account for much of the gravitational structure in the universe. The other possibility is that our understanding of dark matter itself, including how much of it exists, may be fundamentally flawed. This conundrum is based on data collected by the European Space Agency's Gaia satellite, which has provided highly detailed positional information for nearly 2 billion stars in the Milky Way. These observations have led astronomers to reassess stellar motion, especially in the galaxy's outskirts. The speed at which stars move is a crucial clue in determining the total mass of a galaxy, because the gravitational force affecting each star depends on that mass. A recent study using Gaia data calculated that the Milky Way's total mass, including gas, dust, stars, and dark matter, is approximately 200,000 billion times the mass of our Sun. While this number is still vast, it is about 5 times less than previous estimates. This doesn't mean visible matter has disappeared. Rather, it may suggest that there is far less dark matter than previously thought. However, estimating the mass of an entire galaxy is notoriously difficult, and this discrepancy may stem from uncertainties in the data collected by Gaia or in the new methods used for analysis. Regardless, astronomers will continue to study these anomalies. We will keep you updated with the latest developments. If you found this video interesting, don't forget to like and subscribe, and we'll see you in the next one.